This meeting is being recorded.
So when we have enantiomers, there's a challenge to separation of them because we know that most compounds would have different physical properties that allow us to separate them. But enantiomers, we've seen, have the same melting point, boiling point, etc. Right? They have identical physical properties. So we can't use distillation to separate enantiomers because they have the same boiling point. We can't use recrystallization normally. We'll see some ways that we can to separate these because they have the same solubility. But we normally could use recrystallization for compounds with different solubilities. But we can't separate, right, the enantiomer from its race mate. So we'll have to find other means. So some ways of resolving or separating enantiomers was first discovered by Pasteur, and he did this using tartaric acid salts. So tartaric acid is found in grapes, and only the one enantiomer is in nature produced, but he was able to obtain a racemic mixture, so a 50-50 mixture of the R and the S enantiomers. And he treated them in a way that he created the salts of these tartaric acids. And he noticed that the different enantiomers form different shaped crystals, and he actually separated these by hand using tweezers. Then he dissolved these in water and then looked at them with a polarimeter, and to his amazement, he saw that they rotated plane polarized light in equal but opposite directions. So Pasteur is credited with this relationship of enantiomers. And so that's one way that you can hand separate crystals by shape. But usually that's a little tedious and time consuming. So we can use something called a chiral resolving agent, like we see here. So in either an S or an R, chiral resolving agent is used with a pair of enantiomers in our mixture here. And what we create are diastereomeric salts. So we use the same resolving agent here to create a salt with each of the two enantiomers. And now we have different physical properties that we note are with diastereomers, so we can more easily separate our enantiomers, and then we can treat with a base, and then we can create those separated enantiomers at the end. We can remove our resolving agent. So there are some additional methods of resolution of enantiomers. So we could use column chromatography, something called affinity chromatography, where different compounds have different affinities or different attractions to something called an adsorbent. So we have a glass column, and then it's packed with this adsorbent, specifically a chiral adsorbent. So the enantiomers would interact differently as it passed through. So the R and the S would absorb it different rates as it passed through the column. And this is a very common way to resolve enantiomers. So because we know that physical properties are not different with enantiomers, but their interaction with chiral compounds are different depending on if they're R or S. So you should know some of these concepts, both for your lab on stereochemistry, some of the questions asked, and then also for your next test.